get going. This is our agenda today. We're going to go about rapid prototyping. So for the season, especially being a 6-week long full season, I know 2020 they're getting rid of that, but you still want to prototype quickly, right? You don't want to like wait until the end of the 6 weeks and hope you don't have an intake. Hey, guess me, you're going to lose everything, right? You have your advantages, and you want to like figure out what mechanism you're going to build. Like, are you going to build a shooter? Are you going to build an elevator? Then you're going to go about parameter evaluation. So you're going to figure out what mechanism, like should the wheels spin faster, should the ratio be different. So then we're going to go about how we're going to build these mechanisms, and then we're going to go about like different robot case studies, like various teams at One Worlds, etc. So prototyping. So prototyping is the process of designing, testing, and evaluating different mechanisms. You're creating mock-ups of different mechanisms to figure out if this mechanism will work, like in the game. You want to build these quickly. You want to use cheap materials because you're probably going to be cutting and drilling into these materials. You don't want to use like metal. You don't want to use carbon fiber. Of course, you don't want to use them. You want to focus on adjustability. So, like a good resource for that could be 80-20. You can like move stuff quickly. You can move instead of like continuously drilling holes in wood. You can just use 80-20 and slide it around. Figure out your best, center to center distance of the wheel. So you have your advantages of prototypes. You have to, decide your designs. You have to figure out if it's clear or easy to make. If you can't build something and like, for example, last year, we thought we could build something that could shoot through our elevator, but we realized that we didn't have the resources, we didn't have precise machining, so we had to figure out something else instead of shooting through the elevator. And then prototyping also helps you generate your various measurements. So some teams usually just CAD their entire robot and manufacture it without prototyping it. So this might be very nice, but you never know because these measurements might be slightly off, so you're not getting the most effective mechanism. So a team could be like 971, they CAD everything, but they don't usually prototype the exact mechanism they're CADing. They usually like put wheels on the sides and then see if it works, and then they just use those wheels. But those wheels may have different effects on different size differences. So with prototyping, you don't have to guess at geometries, because if you have a prototype that works, just measure everything up, make a final one, and you're done. That's your mechanism. So this is like the general stage of prototyping. You want to start off with like selecting your concept. You want to go about like specific design criteria, and you want to go about building it. And then you go recording your prototype to see, is it a good intake? Like you want to measure the size differences and the effect of the size differences, the effect of like, wheel speed, effect of belt tension. And then you're going to evaluate this, and if you think you can, go a bit further, then you can go back to build stage, and then keep on, working on your past prototypes. So prototyping for concept selection. You want to have a good idea on your robot strategy. So I'm pretty sure there are other presentations here that go about like figuring out what robot strategy is. So in a brief summary, it's basically figuring out what your robot's going to do like in the first few days of build season. So you don't want to like continuously debate among your team, oh, should we have a 6-sim drivetrain? Should we have a 4-sim drivetrain? You want to usually figure that out in like the first 6 hours of like the game release. You want to figure out, you want to have a good general design criteria. So you don't want to like, oh, you should have the best intake. So you're not actually like specifying like what the best intake is. You want to say, oh, our intake's the best, but it intakes it in every orientation, or it's a touchy owner type of intake. And then you want to brainstorm, of course, with your other teammates, because people might have better ideas than you, and it's reality. And you want to test and improve on it. So, yeah. Generic design criteria. So you want to figure out what your subsystem needs to accomplish. So you want to focus. So, for example, I'm going to take a lot of 2018 examples because I'm hoping it's prominent. But say you want to focus on being an effective switch and power-up robot. You want to quantify these requirements. So you want to make known that these are your goals. For example, you can say that you want an intake that intakes in all positions. You want to have a good grip on your intake. So you want to write these down somewhere on a whiteboard, preferably, because you don't see it. So you want to have those ideas, and then now you go back to the next stage where avoid using language that suggests a particular design. So, for example, 2018, you could say that we could shoot power cubes up. I know Rotor Raptors this year, they had a shooter, so what you want to say is we want to lift, or you want to move the power cube from the bottom to the top of the scale. You don't want to say we should lift the cube, or we should shoot the cube. because then you're gonna like focus on the specific mechanism you're talking about. So if you're saying, oh, we want to shoot the cube up there, you're probably gonna build a shooter, or we're gonna lift the cube up there, you're probably gonna build an elevator. So for different games, there might be various mechanisms that could be more effective than just what worked before. So it's great to like prototype these various mechanisms and see which one is most effective. Brainstorming. So there is no bad idea. I know a lot of people like, okay, instead of like having a thing, we should just have pneumatic intakes. That might be a bad idea. We're gonna go about that later on, but you want to look at past FRC and FTC games. So multiple years, FRC games have been closely related to the FTC game that releases like a few months prior. So you want to look at these games, and if you have time during off season, like which is now, you want to test or CAD or design various prototypes that might work for the FTC game, because you might figure out, oh look, this is the exact same game in FRC, so you already have a head start among all the various other teams. So like a good idea is using like in your off season and create a game based on the teaser. So last year, 2018, we looked at the teaser and said, okay, we need to manipulate cubes somehow. Because all these power-ups and all these pixels, we thought we would manipulate cubes, and well, we had to. So we built the elevators, we prototyped various elevators during off-season, and then we realized that's the game. So I guess that was, a good head start for us. Another real key point is the obvious idea may not be the best idea. So 2014, does anyone remember 2014 game? No one? What is it?
It's like high aerial assist.
Aerial assist, there we go. So you had to shoot like yoga type, yoga balls? Yoga balls? Yeah. It's like these big balls like that. You had to shoot in like a high goal. So that year, everyone thought you were gonna like, use a pneumatic kicker or a pneumatic launcher. But a good team, I'm hoping you all know this number, 254, they actually made a shooter. And they won, I think. I think they won the world that year. But they made a shooter, and no one else did it, because they all thought, oh, we got to use something that kicks the ball up, because that's going to be the most effective. But that's what they made. So they made a wheel shooter for 2014, and it was pretty effective. And you can see on the left, that's their prototype robot. So they basically made the entire robot with like rough measurements out of wood, and the concept worked. And that's the main key factor of determining that the mechanism will work or not. So they knew, okay, shooting works, it's very effective, time to CAD it all up and machine it. So that's what they did. Okay, so now we're prototyping for parameter evaluation. We want to, of course, again, have a set specific design criteria. We want to determine various mechanisms and their variables for it. We want to prototype and design these, of course, and then experiment and evaluate these prototypes. Okay, so be specific. You want to specify and figure out the details that separate your good and bad mechanisms. So you want to have an objective goal. So one goal could be like having a catapult that scores 80% of the time. So having set numbers like these, it's actually very simple. You just have to test your various prototypes and then figure out, okay, you shoot your ball like 50 or 60 times, and then you do some simple math and figure out, oh, it only shoots 70% of the time. So from that point on, you know that that mechanism might not be as competitive as various other mechanisms your other teams could build. You could also say that roll claws or wheeled intakes must grab the game piece within 1 second or half second of touching it. So this also removes driver specific. So you want to think about set goals for every mechanism. So and that's what I said before. And you want to have a set goal for detailed aspects of the mechanism. So another example would be intakes. You want to have like a set intake speed, so you could make an Excel spreadsheet and then go about. So this speed, say 5,000 RPM, and then you can see how long it takes for the robot to intake the cube. And then you can go about testing various other RPMs and see which is the most effective at intaking. You want to know various design variables. So you want to simulate true conditions while testing prototypes. So true conditions, you don't want to use human influence when testing your prototypes. That actually is very different than what your robot does, because humans have various angles of movement. You could alter your mechanism bias. You don't even know it, but you're actually having bias on your mechanism. So what you want to do is you want to put your mechanism, say an intake or an elevator, on a few caster wheels or on a robot cart, something preferably that's low so you can actually intake stuff on the ground. And then, test it with that. You don't want to use people like pushing roller carts around, so it's very effective using just a simple cart with caster wheels on it. A few variables include roller, wheels, materials. So that's what this slide is. You can see the various things that determine like various intakes. So on the right, you can see that was our first prototype that broke after the first match we played. So you can see how like the other team 1619 on the left, they use like rollers instead of wheels. So these are all the various things that could determine what your mechanism is going to turn out to be. So rollers are like long things that have rubber on it, especially like 1-inch tube extrusion metal. So on the right you can see like those AndyMark compliant wheels, 4 inches. So all these various sizes, the material, especially the green wheels. Those green wheels have gone sold pretty quickly during build season, specifically because their durometer was very low, which means it was very soft. It could grip on materials very easily. So that's why we use those. And then the team on the left, they use that orange belt. They use those, and so you don't have anything that's rubbing against the cube. So all these variables, they prototyped it. You can see which one works the best, and then you just implement it on your final design. So another few variables could include like intake, claws, and shooters. Team on the left, that's 254 again. That's one of their prototypes to the 2017 game. So they used a claw. Of course, they didn't have the claw because they figured out that prototype wasn't effective. They had no way of lifting the cube, lifting the gear from the bottom. So they scrapped that idea, but it could be useful in other games. So you want to continuously prototype with various mechanisms because you never know which one's going to be the best for that game. You can also have shooters, etc. Okay, so now we're going to go out for the how of prototyping. You want to design the prototype. So you want to use as much as FRC legal materials as possible. So like you want to use bag motors, sim motors, 795s, maybe Neo motors that came out a few days ago. You want to implement these adjustable components. So adjustable components is, as I said before, 80-20. There's these nice slots you can just put some gussets on, and then you can just continuously test the different size differences and figure out which one works the best. You can also test various, surgical tubing, etc. So that's just one example. So that's 971 on the right. So they tested with wood. So they had a laser cutter. Some teams may have like good machining capabilities, and they could prototype very quickly. But you don't have to go. You don't have to be so extra. You can just put some 2x4 on a wheel and then test it with drills. And then on the left is the Versa gusset thing. Versa lift. Yeah, there we go. It was actually a very effective. You can actually use it as a final prototype, final robot, but 148, they can't do that. They got to sheet metal everything. So that was their prototype, and you can see how their final robot has changed a lot. So that was their elevator from 2015. They figured out, okay, the bearings are aligned. You want to have a specific height, and if it works or not. And then a team on the right, they figured out, okay, this is the size differences between the two wheels on the left and right. They figured out that worked the best, and then they put motors on it and they catted it and then machined it. So those are really great prototyping resources for structural prototyping. So powering mechanisms. You want to use motors. You want to use gearboxes, planetary gearboxes, single dual shifter gearboxes, variable, all that stuff. So gearboxes, they usually allow, they have a lot of angles of movement compared to like pneumatics, because pneumatics get you from one point to another point. And so it's because it's a one shift thing, so it's very repeatable. The only concerning thing about this is, your air tank might not be enough to, continuously provide compressed air towards your pistons. That's where air tanks come in, but if you have your air tank running throughout the entire game, your battery is going to suffer dramatically. So you might want to have like multiple air tanks. You might want to have multiple air tanks and fill it outside your robot, and then just use it towards your match. That's what a lot of teams did last year, like Darkside especially. They had a shooter robot, so they relied on pneumatics. So they had like 20 or 15 air tanks, and then filled it out in their pit, and then went to competition. And then motors, you can use planetary gearboxes for Vex. So I know 80 Mark sells planetary gearboxes, but they're not that heavy. They're pretty heavy, and they're not as effective as Vex's planetary gearboxes. It's an expensive, it's very expensive, especially when you're getting started with planetary gearboxes, because it's a large initial investment. But over the years and as you get more confident with FRC, you can get these planetary gearboxes and figure out, oh, it's very simple to build mechanisms with planetary gearboxes. One thing with planetary gearboxes is don't use the 1-to-10 ratios. Don't use the 1-to-10 ratios on the planetary gearboxes because they only have like 6 teeth in the center sun gear, and those strip very easily. So if you are using planetary gearboxes, use like 5-to-1s, 4-to-1s, 3-to-1s, 7-to-1s, and 9-to-1s. Yeah, variable movements. So with motors, you do need encoders. So those just measure the rotational output of the shaft. JV calculator. So are there any rookie teams here? Great. So most rookie teams usually don't know what this calculator is. So it helps you figure out your motor ratios, and you can just go to Google or Chief Delphi and search up JV calculator. Someone named JVN from 148 made this, and it's very effective actually. You can clearly see how you can change your ratios and test with different ratios on this calculator and figure out which one works the best for putting in your loads and putting your arm lengths and putting your rope length, as you can see on the right, and your different motors. So each motor has their own torque output, has its own speed, variable speed, and with these ratios they also change the output speed. So instead of testing each motor, each gearbox in real life, you can just test it on here and see which one works. However, this might not be that accurate because last year we actually did a 1001 on our elevator, and it said it would lift it in 0.8 seconds, so we're all static, but it ended up not lifting at all and burning a couple of motors. So it's not that reliable. You might want to tone it down a bit. So instead of 1001, you can 20-to-1, etc. So it's not that trustworthy, but it is a good resource if it works. Okay. Case study. What is one similar thing with all these robots? Not blue. Not blue.
It's all two.
They all have. Anyone?
Smoke.
Smoke?
Smoke
Probably, but that's not what I'm looking for.
Drivetrains used to be fairly standard.
Yes, that's the point. They all have the same drivetrain. Why? Because it works. So that's one thing with prototyping. Don't prototype your. Oh, that's another one. So don't prototype your drivetrain. Just use a simple tank drivetrain, especially if you're a rookie team. Just go to AndyMark, get the kit bought. It's very simple to make. Should take you a few weeks if you're a rookie team. But you don't have to prototype with various different mechanisms if you're a new team. You can just put 6 wheels on the side of your robot, and that's a drivetrain. It's that simple. You don't have to go with various wheels like mechanism wheels. You don't have to go with Omni wheels. You don't have to go with swerve drive, because that's very complicated. So just stick with this simple tank drivetrain. It can literally be used for every game. I don't think there's one game that you could not use tank drive. So just use it. Okay, another case study. There's one more thing. Not drivetrain, not blue, not the number, not smooth like sand. What is one thing that's similar with all these 6 robots?
Active intake?
Yeah. Okay, so you probably knew this because you saw my presentation, but active intakes. That's one key thing with making mechanisms. Have a continuous intake. You want to have rollers, as you can see here, they all have roller intakes. You want to have roller intakes. You want to have intakes that have wheels that spin. You want to have these continuously moving. That makes it touch its own intake. You don't want to have an intake that relies on the drivers because it's going to take a lot of time during the game. And although you might think, oh look, we have an amazing driver, he can get the cube with two pieces of metal and then there's the clamps on. That's not going to work all the time, especially if you don't have a great driver. So you want to make a continuous intake with the rollers or wheels. Just touch the intake and intake. It's in your robot. intake on the left, 1323 type intake. So that's a touch and roll type of intake. They have rollers on the sides. If it touches it in one area, it's just going to come inside the robot, and then you have access to the robot. But the intake on the right was actually our freshman prototype. So we usually have freshmen that prototype various mechanisms on our team during build season because they have nothing else to do. So they built that as a prototype, and although it was a good learning experience for them, they did realize that it didn't work especially during the testing stage. It didn't work as well as the intake on the left. So especially with robotics, especially in FRC, you have something called the withholding allowance. So it's actually very helpful with prototyping. So you're allowed to bring less than 30 pounds of manufactured parts with you during competition. So you know how there's going to be bag day for next year, but not for 2020. But for 2019, you're going to be allowed to bring less than 30 pounds of manufactured parts. So if you don't have something that's completely made yet, or if you have some final prototype, but you still have like small minor adjustments to make, you can just keep this outside, bag your uncompleted robot, and then work on this mechanism outside of your robot, and it's still going to be legal. And then you just go to competition, and then unbag, and then mount your mechanism, and then you're done. It has to be less than 30 pounds, of course. There's also another limit. I don't think there is a limit, but you can bring COTS parts, off-the-shelf parts, and you can bring like unlimited of them, I think. You want to keep these, you want to keep a backup components in case something broke. So Pitt County, our intake broke like 3 times. So we actually had to like make an entire intake new with like scrap pieces of metal. So we just drilled holes in them and put wheels on it and it worked. So, in fact, that mechanism that we built in like 20 minutes was more effective than the mechanism we spent 6 weeks on. So I don't know, it might work for you, it might not. So so you can work on your mechanism outside your bag day, but do not rely on this. So a lot of teams, they procrastinate a lot. Oh, we don't have a drivetrain. I guess we can just bag whatever is left and then make a drivetrain for competition. First of all, your drivetrain is not going to be less than 30 pounds. The other thing is you want to have something that works for competition, because you don't want to rely on oh, we don't have this one mechanism. But if it's your key mechanism, just put something in there. So and then work on make something else and then work on that outside of your bag. Because you want something that works in your bag before you bag it. Okay, programming. So I know this is an engineering presentation, but I will include programming as well. Autonomous equals huge points. So one of my programmers told me to include this slide, so I'm doing it for him. So as you can see, like the past games, you can see how you can get a lot of points with autonomous. So there are a lot of teams that can do amazing things with auto, but the saddest thing for me to see during the auto stage is to see a robot just stand there. Like you have this entire build, you have all this off-season time, especially in rookie teams. If you've never done this before, there's something called baseline auto, where you have to cross a baseline. You can prototype that, you can just code it up, and it'll work every year from that point on. So you can just work on it during off-season, and then go about that from, like when the season starts, you already have a head start, and you might already have working baseline code. So make your drivetrain, test it out, and then you already scored like 20 points for your alliance if you have baseline. So, it's just something to keep in mind if you're a rookie team. When to skip prototyping. So if you've done something like multiple times before, so if you're like if you're a team like the 3 digits, if you've been around for like a couple of years, you know things work. So you don't have to, especially if you've been there in 2015, elevators work. So this year you could have built an elevator. However, we built an arm in 2015 because we're 5190. However, okay, so so if something works, you can just skip prototyping it, and just make a final version. Especially like mechanisms that are hard to prototype, like elevators or arms, especially full-bodied arms, like arms like this big. So you can just CAD it up, especially with arms that are like made like precision, especially elevators, because if you have bearings that are not aligned, your elevator's not going to go up with friction. So you want to CAD something up. So if you're a rookie team again, if you don't know CAD, it's a great time to learn CAD. Make various mechanisms that could work in CAD, and when build season comes around, you already have like experience with CAD, and then you can just make something that you can't prototype, like elevators, and then just build that. If you can't finish in time your prototyping, it should be adjustable in your final robot. If you can't finish your intake, for example, and you don't know your proper tension, you don't know your proper wheel-to-wheel size, if it's already like, oh, bag and tag is like 2 days away, or sorry, 2 hours away. Yeah, so during wheel season, you don't know what 2 days and 2 hours away. So you want to have something that works, of course, and if you still have your version 2 of your intake, just put that in your bag and tag it, call it a day, and then work. So your competition's usually going to be a week after the first bag and tag day. I think it's the second week after bag and tag day in North Carolina this year. But you still have all that time to work on you still have more time to work on your final prototype. And then, if it's less than those 30 pounds, you can bring it to competition, mount it on, and you probably have a very competitive robot. So that's just something to keep in mind. Recording results. So this is almost the last stage of recording results. So you want to change one variable at a time. So as I mentioned before, variables include wheel size, material of the wheel, tension, belt tension, if you're using belt or chain. Various other things could factor, like the size of your mechanism. Especially like the past years, you could actually have you have to start inside your frame perimeter and then drop a mechanism down outside your frame perimeter to intake stuff. So you might want to have that as one of your variables as well. So sometimes you might figure out, when you see something and it doesn't work as well, and you immediately know, all we need to do is slow down the wheel and increase tension. Don't do each of the don't do both of those at the same time, because you don't know which one's actually the one that's going to affect the performance of the overall intake. So what you want to do is, these are the 2 factors that should be changed. Should change your motor speed, and if that works, then you don't even have to change your belt speed. Because if that works and that works, you're done. You don't have to do anything more to that prototype. So make many prototypes and adjustments. So especially during build season, hopefully you have a lot of people, you have a lot of freshmen, so they're going to build most of our prototypes. If you are a small team, then you can just focus on 1 or 2 prototypes. But make sure you figure out or debate among your team what are the 2 best prototypes or the best 3 prototypes you should build for this one mechanism. So of course, multiple games, you have various mechanisms in your robot. You have collectors, you might have shooters, you might have elevators, you might have arms, intakes, etc. So you want to have, if you can't build all of those, especially if you're a new team or a team that is lacking a lot of resources, you can just stick with one. You don't have to do every single thing in the game. So that's where a strategy comes in, and you're determining whether you can do something or not. So if you're a small team, if you're a new team, you can just focus on doing power-ups and focus on the switch instead of building a full-scale elevator that doesn't scale. So that's just one thing to keep in mind. Okay. You want to test testing and powering your prototype. So you can skip the motor mounting stage entirely, especially if you're in the first stage of making your prototype. So one thing you can do is take the drill. Hopefully you have more than 1 drill. So take 2 drills and then add a hex adapter to it. And then you can control your wheel. If your wheel's on a hex shaft, you can drive the wheel with your drill and then test and then move into a wheel into the game piece and see if it works or not. So although it is human influence and you're in the first 3 or 4 days of prototyping, so this will work. It's very effective, and then from that point on, something works, and then you can put a motor on it and then test it without human influence. So another thing we did was we used an RC controller, and we changed speeds precisely. So there's actually, I'm not that good with it, but there's an RC controller online on Alibaba. So you can just connect it to your motor. It's a it's wireless. So you can like go back, and then it's like a very, very precise motor changing or motor speed changing device. So you can properly change and like get RPMs like down to like the thousands or down to the hundreds rather, and then figure out, okay, so we're at 5,000 RPM, then we can go to 4,999 because that will obviously change something. And then you just figure out, okay, so that works. So make a pneumatic test board. So this was our pneumatic test board. I know a lot of things are not connected, but this is a concept. So you want to have like a spare compressor. You want to have some air tanks. You want to have those pneumatic valves, and etc. So you can have this, especially if you're in the prototyping stage. You just want to have this around, and then figure out figure out which pneumatic prototype or which pneumatic dependent prototype will work or not. So if you have various pistons on your prototype, so if you have like an intake that clamps, of course, with pistons, you can just test it out with this instead of slapping on an entire robot compressor and stuff onto that. Because you can move this around, and it's very compact. I mean, it looks compact, but it's like this big. It's better than having an entire robot with your 2 pistons that are controlling your mechanism. So you can use this on various other mechanisms, and if you, that is not an FRC legal compressor, but you don't need an FRC legal compressor because you're just compressing air. So, yeah. Okay. So another thing you could record is, you're measuring the effective wheel speed. So another team, they tested effects of wheel speed by, measuring the length, measuring the distance the wheel was shot out from with varying wheel speeds. So, of course, there are a lot of other factors that could affect the overall output of this wheel speed change. Could be like, wind, etc. So it might not be that effective, but it does give you like a baseline of something that might affect your final prototype. Okay, now we're nearing like the last stage of prototyping. You want to figure out which prototype fits the criteria effectively. Was there a design that was easier to build? You want to evaluate prototypes for each subsystem at a time, and you don't want to waste time between 2 ideas. So now you have set intake. You want to figure out which one fits your criteria. So you have, you say you have a pneumatic intake and you have a roller intake. Now you want to be specific. You don't want to say, let's pick the best intake. You want to quantify these goals and then say which game piece holds on the cube or holds on to the game piece, which intake holds on to the game piece the best, or which intake takes the cube and holds it quickly. So you want this is easy to figure out. You already have these mechanisms that work, and then you just test these various mechanisms and see which one fits your criteria effectively. So you want to do what is best for your team, as I said before. If your team's really good at making a specific type of mechanism, like if you're a team that almost always built like a shooter robot, and if you're not as confident, especially if you didn't prototype during like off-season, and if your team's not like confident with building other various complicated mechanisms, it's fine to build a shooter. I mean, there's no point in having a mechanism that doesn't do anything rather than having another mechanism that does something. So something's better than nothing, obviously. So you want to choose, although it might not be the fastest, the best mechanism you can build, it's something. It's better than having an elevator that doesn't move up, or elevator with a lot of friction, so you're continuously burning motors after every match. So it's obviously better than that. Don't waste time choosing between 2 ideas. So during the first 2 weeks of our build season, I'd say it was actually the worst because we were continuously debating on like 2 different ideas: shooting through the elevator or shooting through the back of the elevator. We spent a lot of time just debating among that without actually testing anything. So don't do that. Don't be us. Okay, you have this idea, you have that idea. Prototype both of them. See which one works better. And then, if yours works better than them, you can, brag it, or you can just, make it, and then you're done. So you also have various other things that could be linked together. Like 2017, you had to shoot balls and you had to collect balls from the floor. So the shooter and the agitator and hopper were linked together very closely. So you might want to pay close attention to these various mechanisms, and you might see a very close correlation with these two, because changing the speed of the hopper or the agitator that feeds balls into the shooter might affect the shooter speed. So obviously again you don't want to change both at the same time. You want to change one speed and then the other speed, and then mark down which one changes the output the most. So okay, so now we're going to go about various prototype case studies. So yeah, I think I showed this picture before, but this is very simple prototype. You don't have to use, you don't have to. These are all scrap materials we had because we are a 6-year team. We had all these scrap materials we've been saving up from the previous years. We just all that metal has various holes in it. So you just take something from your scrap bin and then put it together. If it works, then you make it out of more premium parts. Picture on the left, picture on the right. That was actually used. That was someone made that intake with premium parts. So they didn't actually prototype that before, and they just made it, with paper sketch drawings, and it worked, but it didn't work well. I think that person's in this room right now, but I don't know. So yeah, so that's what you don't want to do. You don't want to make various intake prototypes with good materials and then realize it doesn't work at all. So yeah. So you can see how you can test the picture on the left. You could put something on the card and then drive it into the game piece and then see if it works or not. So that's just one way of testing various prototypes. So of course there's actually great resources online, especially during build season. You can just Google 2018 FRC prototypes or 2019 FRC prototypes, and you will get a list of teams trying to show prototypes to the world, trying to help other teams as well. So that's just another great resource if you are a rookie team. So the picture on the right, yeah, that's a picture on the okay. So that was actually the second prototype for a winch. So that, of course, you can't actually prototype a good winch or a good elevator winch. You have to design that in CAD. You have to figure out proper measurements so it fits in that small confined area. Because that wasn't it was 2.5 inches by 13. So it had to be in a very confined area. So you have to CAD it. You can't just drill holes into some piece of metal and hope it works. So you want to CAD that out and see what. So yeah, these are just various angles of testing your prototype. So of course, that was our practice robot. It was pretty messy. Okay, that's enough. Okay, so yeah, you can clearly see the difference between the final winch and the previous prototype winch. So before we had chain outside of tube. I don't know if you can see it, but there was chain outside of tube. That actually makes it easier, especially if you're in the prototype stage. You don't want to waste time on a prototype. So you just put chain, it works great. Then you go on this stage, and then, oh, now how do we save space? So you can put chain in your tube. You can use those plastic Versa blocks, and then you can put some 775s and on Versa planetaries, and hope for the best. This is another great team. So these guys actually, especially if you're a new team, these guys provide blogs almost every few days during build season, showing various prototypes they're working on. So you can see how the picture on the right, they made that robot day 3 or something. So they made it entirely out of wood because they knew what size they had to do. So they put 4 omnis on it. I don't recommend that, but they did that. So they put 4 omnis on it. They made an entire full robot out of wood just to get the measurements right, just to see. And they use that wooden robot to test their intake. So since they knew that their final robot was going to be an arm, they already decided that. They said, okay, now we need an intake that intakes it for at an angle, because as you can see here, their intake is angled because their arm is also angled. So that was one criteria they had to fulfill in order to have successful intake. So you can see how on the picture on the right, they actually use 2 different types of wheels. They use Fairlane wheels and they use those blue compliant wheels. So Fairlane wheels, I think I'm pronouncing it right, but I don't know. So those wheels, they're actually really good for flywheels, especially with shooter. So you can see how there's grooves in it, so that actually provides more momentum for the wheels, so it allows you to shoot balls further out than using compliant wheels, especially if you're at high RPMs. The wheels on the right, the blue wheels, those actually expand, especially if you're 5,000, 8,000 RPM. However, the wheels on the left don't actually expand that much, so you're not actually changing any your diameter values. Okay, TOE 54. So this is one of their prototypes of their intake. Of course, that wasn't the intake they made. In fact, that year, they didn't actually prototype their intake until week 5. They decided that their elevator, their arm, and their drivetrain was the most important things. And then they figured out, okay, we could just copy an intake from another team. And they did. They copied it from 1323. So that was their strategy of the year. So you can clearly see how they still had a tested intake because they needed something to put in the bag before bagging tag. So yeah. So this is what they did as well. They catted something up. So the picture on the right just shows you how you can simply make sketches and that are constrained to each other. So I don't know if you know that, but Picture on the right, that was 254's arm. So they CAD everything and then they machine everything. By everything, they literally machine everything. Every inch of their robot is machined. So they had to CAD everything up, and then they figured out, okay, so before they CADed their entire arm and an elevator mechanism, what they did was they made a sketch that just shows like the side layout of the intake and the arm. And they wanted to figure out what's the best measurement for the arm and the best length of the arm so that the intake can fold back into the robot holding a cube so they can shoot through the elevator. So that's just how how people should, prototype various mechanisms so you don't waste time during your CAD stage. Because CADing also takes a lot of time. Because if you have, if you have a 3D model and then you figure out, that hole is actually slightly off, it's going to be a lot harder to change that one measurement when your entire robot's already, CAD and built and machined. So in the picture on the left, they use tank drivetrain, of course, because it works. So they CADed it up. You don't need a prototype drivetrain because you can't make a prototype wood drivetrain that works, like a proper drivetrain, because the wood, you're not going to get proper tube extrusion out of wood, and you're not going to have the proper strength and durability of the drivetrain when you're colliding in different things. So you can see on the picture on the left, that was just one of their designed gearboxes in CAD. I know it looks pretty complicated, but once you get more accustomed to these different gearboxes and different mechanisms that you could design, you'll figure out it's pretty easy. So these guys had a dual-speed gearbox. So the picture on the left, as I mentioned before, with the various gearboxes and motors you could use, they used the dual-speed gearbox on the left. So this is the shifter. That actually shifts between two gears. It's similar to how a car works. Hopefully, anyone who, if you have Hondas, this is not how Hondas work. They have CVTs, much different. So if you like different other cars that have 6 gears, manual transmission or automatic transmission, so the car usually switches between gears for efficiency. So you start off with a high gear because it's hard to start moving, then you continuously move faster and faster. So that's why you with 2-speed gearboxes, especially in your drivetrain, having 2-speed gearboxes are very helpful for acceleration. Especially last year we had problems with acceleration. So our gearboxes were geared up for like 21 feet per second max, and then I think 12 feet per second low. So we actually never reached 21 feet per second high. The only speed we've ever reached was like 16, and that was in high gear. So that's why you want to figure out with Jamie and the calculator, you want to figure out the best speeds and best torque values and best ratios for your gearbox. See which one works the best. So yeah, that's our final one. It's pretty nice. Yeah. Okay, 971. So these guys, they actually, they CAD everything as well, like 254, but they make it out of sheet metal. So I know there might not be a lot of teams that can use sheet metal, especially if you're a rookie team. So you can just CAD something up. They also use rollers that year, so you can clearly see how the rollers might be very effective for taking different mechanisms in and not tearing up your ball as well. Because 2016, those balls were very soft. So if you had like a very rough mechanism, it could tear the ball apart. And I think that was like the yellow part or red part back then, but I wasn't here then. So they CAD everything up. They tested. Okay, so they prototyped the drivetrain. So I know I said don't prototype your drivetrain, but for some years, especially in 2016, you have to go on all these various rough terrains. So you might want to put like some wheels on a few pieces of wood, and then figure out what's the best the height difference of the wheels, so you have like the best turning capacity, and it can actually go on various rough terrain. So that's one thing to keep in mind if we are again in a rough terrain game next year. So 971, same team, same year. So you can see on the right how they they prototyped they use 80-20 as a prototype resource to shoot balls. And the picture on the left was their final machine shooter, sorry. So that was the same picture on the right that I showed you, that they were testing various speed differences and how the speed differences affected the distance it shot through. So They use sim motors, but you can clearly see how they, on the right, they use the sim motors, but on the left, they use bag motors. That was actually not on that picture because they had it various, so another mechanism was using those bag motors, and then that was, transmitted, the rotational motion was transmitted to this mechanism, the chain, but it was very complicated. So you don't have to be that complicated, you can just, if you don't think you should like machine these things, you can just, put 80-20 in your robot and call it a day. I mean, there's no harm in doing that if it works, so. Okay, so yeah, this is our final robot as well. So you can see how their arm and intake back. I know this is all complicated, but it's just a great thing to see how other teams did something. So you could take inspiration and work on these various aspects of your robot for a few years next. So that's what we do. We actually we go back to past years, see which game is most similar to this year, and then just copy everything. I mean, at least try to copy everything. But so picture on the right, these rollers are their intake. I mean, rollers are pretty effective, especially in that year's game. And then they switched on to a mechanism powered intake because mechanism wheels, they actually, they transmit. If you're rotating in a specific way, they actually can move the game piece towards the center of your robot. That's what they did over there. So they have an omni wheel in the center, and the omni wheel just brings it into your robot. However, the mechanism wheels on the right, they move it towards the center, so you actually have a larger intaking space than just having a few rollers. So that's pretty much it. I know this presentation went by pretty quickly, but one more thing I just want to mention is you want to watch other competitions and robots. So I noticed a lot of NC teams and a lot of other teams in other districts. They just think that FRC is limited to just that state, but in reality, FRC is worldwide. FRC is global. So just don't stick to watching NC regionals. Just so there's week 1, so you can watch regionals like Palmetto, which happens in South Carolina. Watching these regionals show you how different robots work with their robot strategy. And then you want to watch West Coast regionals. These are my favorite. They're the most competitive. That's where those teams I showed you, that's where they compete, like San Francisco or Silicon Valley. It's great to watch these regionals because then you can figure out what's the best strategy for your robot and how you should play in order to get the most points. You can also, and also that's the time where good teams' robots are leaked. That's the best time of the year. So 254s, all their stuff's leaked. You can take inspiration from that and then build something from that. So that's one of my favorite mottos: steal from the best and invent the rest. So that's what you should do as well. Prototyping resources. So especially during the build season, although you might think everyone's confined to their own robot, they're trying to hide everything from other teams. There are some teams that are open to all their ideas. Like Triple Helix, for example, I think they're a Virginia team, but they continuously provide videos on YouTube on all their prototypes. Like 2363, that's their team number. They're on YouTube. They have all these. So when the first few days, they laser cut their wood prototypes, and then they just record it if it was working, and post it on YouTube. So if you are looking for inspiration for your intake, you just look at these guys, and they probably have something on YouTube by the first week of build season. So then you have robot in 3 days. So these guys, I'm pretty sure most of you have heard these, but these guys build an FRC robot in 3 days. So they usually stay for 72 hours, and they build a robot. So they have a reveal video that they release at the end of 3 days. And a lot of teams usually look at these videos to gain inspiration and figure out what they can take from their findings and their research on their mechanisms and implement it in their robot. That's just another great thing of YouTube. So you can figure out which one works. Spectrum's 3847. That's the team number. Their blog. That's their website. So these guys, they don't provide they provide blogs every 3 or 4 days during build season. But these are in-depth blogs, so they show you they're spreadsheets. They show you why this wheel won't work the best for this one mechanism, and they also show you their CADs. They also show you how their robot's progressing every week and every week. So that's just another great resource, especially if you're a new team. But even if you're a veteran team, it's also great to take inspiration from these various mechanisms because in the end, it's only going to help you. Okay, so before I almost end this, I just want to mention build season never ends. So build season starts in January and it will last until April, until Worlds, because you can continuously work on your robot, and you know, so especially without the bag and tag 2020, so you never have to bag your robot, so you can continuously work and improve on your robot throughout competition. After competition ends, you can see other robots and, oh look, they have better intake than me, time to, you know, copy and paste it on your robot. So that's just a great thing about 2020 no bag. But build season never ends. So you can, you know, don't just stop prototyping it after your first, after bag and tag day or after your first competition. You can continuously, you know, prototype various mechanisms. If you still have your intake, and your intake, you know, it doesn't work as well, you can, you know, keep it outside of your bag and then just prototype it. Okay, so these are the few key points among this presentation. So you want to have good prototyping, and good prototyping is all about, you know, solving various design problems and keeping these concepts simple. You don't want to go very complicated and then end up having a robot that's so complicated you forget how it works. So that's not a good thing. You want to have, you know, quick concepts, and you want to pick up like a quick initial design to work on, and then when you're like coming near the end of the build season, you don't want to scrap that idea. You want to continue working on that one idea, because you already devoted all this 4 or 5 weeks of build season. There's no point in creating an entirely new design that you haven't tested and putting on your robot. So give unconventional designs a chance. So although it might sound weird, like 2014 for example, although a shooter might sound weird for this big medicine balls, but you know, it might work, and it did work for that year. So give unconventional ideas a chance. So use detailed prototypes to figure out, you know, the intricacies of various designs. So you might not have the resources, but you could build, you know, 2 or 3 various prototypes, and then figure out like the specifics of the prototype that, you know, determines whether it's going to be an effective prototype or not, like, you know, wheel speed or belt tension or surgical tubing that, you know, provides tension, or you use springs and, you know, various pistons that could also increase tension, of course. So you want to know when to skip prototyping and build your final design. So this point is actually pretty important, because build season, you know, it's still pretty confined, even with the no bag day 2020, but you still want to have your set schedule, because then you're going to continuously procrastinate and then have, like, you know, a non-completed robot for competition. So it's still good to, you know, stick with the 6-week build schedule. Know when to skip prototyping. So if you can't prototype something, just CAD it up and then machine it in-house, and, you know, just build your final design. So I think that's almost it, but I know we ended up a bit early, but if you have any questions that are, you know, related to our team or our robot or anything engineering related, you know, I'm open. I'm here for like another few hours for our next presentation, but you know, I'm open to questions. And any questions? No? Yes.
I have a question.
Yeah.
Once you're done creating the prototype and then starting to build the robot, you can keep the prototype to like for what's it called? Like you can keep the prototype to as
Less than 30 pounds?
yes.
So yeah, so that's just one thing for the 2019 season. So you actually have a withholding allowance. So even if something's bad in your robot, you can bring manufactured parts or mechanisms that are, you know, less than 30 pounds and bring it to your competition and bring it, and then when you're at competition, you can unbag your robot. It's only for next year because there is no bag in 2020. But
And make sure you read the rules, because that's based on last year's rules. And we never know what first is going to change.
Yeah.
There's a clue.
So just make sure that you read the rules and don't beat him up if he told you something that's not true for next year.
yeah.
It's just protect him, I got your back.
You mentioned getting an RC control on Alibaba. Does any of those work, or is there a specific one you recommend?
I'm not actually sure.
Yeah, so let me talk about
Yeah.
that. So these are just standard RC controllers that you can use for cars, planes, helicopters. There's actually a version that they sell on Andy Mark that works. So it's 2 pieces. There's a RC controller and a receiver, and the receiver uses PWM output. So you can connect the PWM output to pretty much any of the motor controllers that are legal in FRC. And you have 4 or more channels, and you can control forward, reverse, and the speed of the motor. So we actually connected one of the receivers to our robot, and we drove the whole robot with it without any robo-rio or anything. Because it's got, 4 or more channels that you can do. So you can get it from Alibaba or Amazon or Andy Mark, or there's a whole lot of places,
And actually, upcoming for this season, the Neo motor and the Smart Max controllers, you can drive them over USB. So you can actually just plug a computer into the ESC and just drive any motor. They're not out yet, but they'll be out in the next couple weeks.
Yes.
For rookie team, you say that for the most part, drivetrain, you're gonna be exact same, correct?
I mean, if you're getting the kit bot, like if you're going like to the, I don't know where it is, but if you're getting the kit bot, then it's gonna be the same IndyMark chassis for everyone getting the kit bot.
Okay, so is that kind of recommended as far as something that we're not gonna invest a whole lot of time,
I mean, you should get it, especially if you're a new team. You should get it. There's no point in making the other complicated drivetrains if you're a new team. Just buy this and then assemble it. Because there's all instructions, it's very simple to make. And in fact, a lot of teams that are like veteran teams, they also use that drivetrain because it's pretty effective.
The rookie teams get a drive base with their counterparts. The
Yes.
first season, yeah. So you'll get a box that has that drivetrain, the standard 6-wheel drivetrain, in your kit of parts.
Any other questions? So, I mean, I'm pretty much done, so, yeah.